Okay, so today we're going to get to some problems that just look a little bit different and make some connections of what we did in part 2.2 of our two-step equations. So with each of these problems, each are slightly different or just look a little bit different but are done kind of the same way. So with this first one here in the top left-hand corner, again, if I draw my line down here, first thing I want to do is add or subtract, then multiply or divide. So with this, I'm going to add the 3 to the other side first. When I do that, I'm left with 1/2 x is equal to 15. And then what I can do is I can go ahead and I can either divide both sides by 1/2, which again gets the x or the 1/2 to disappear, and I get x is equal to 30. With the one on the right hand side, again, same thing. I've got my line down the middle. I'm going to subtract my 5 first. So 1/4 x is equal to 8. And again, this is I could divide both sides by 1/4. The other thing that I could do is I could get rid of the fraction by multiplying by the bottom, like we talked about in our section 2.2. And so I can multiply both sides by 4. What will happen here is that'll leave me with 1x on the left-hand side, which is the same thing as just a regular x. So x is equal to 32. The next row of problems down, again, still very, very similar. So I can add the 4 to the other side. Get x divided by 3 is equal to 8. And then again, to get rid of the fraction, I can multiply both sides by what's on the bottom. When I do that, I get x is equal to 24. And then on the right-hand side, again, same type of problem. I can go add the 5 to the other side since it's a subtraction of 5 or a negative 5. So x divided by 4 is equal to 3. And then, just like we did before, to get rid of our fraction, I can multiply both sides by what's on the bottom, and I get x is equal to 12. So again, those top 2 rows of problems on your notes are very, very similar. So when I get down to the bottom, that's where it gets a little bit tricky. So when I do the problems here, if you could just put a note kind of over, you can maybe do it, got room over on the right-hand side. I don't want it to get in the way of your work, but I just want you to write that if it's a big fraction, oops, almost misspelled fraction. It's a big fraction, we're going to multiply first. And so with both of these, and what I mean by big fraction is there's not just one thing up in the top of the fraction or in the numerator of the fraction. I've got x minus 7 all divided by 4. I've got x plus 4 all divided by 3. So if you compare it to the fractions that are in the top 2 rows of problems, you see that that's a bigger fraction, it's a wider fraction. And so whenever that happens, I have to get rid of my fraction first. And so to get rid of the fraction, I always multiply by whatever's on the bottom. So here I can multiply both sides by 4. So again, when I do that, that gets rid of my fraction. So what's left on the left-hand side, if I draw my line, is I have x minus 7 is equal to 12. From there, again, relatively easy, I can just add my 7 to the other side. When I do that, I get x is equal to 19. And problem over on the right-hand side, again, same thing. I've got a big fraction. I've got 2 different things in the top. These things are both being, divided by 3. And so I have to get rid of the fraction before I do anything else. I got to go times it by 3, times it by 3. Get x plus 4 is equal to 18. And then I can subtract the 4 to the other side. So x is equal to 14. Again, all of those I could plug back in to make sure that it works. When I would plug this 14 back in, I would have to do the, oops, I'm going to do it in a different color actually. If I would plug that back in, it would be 14 plus 4 on the top divided by 3 and make sure that that's equal to 6. And so I would do the top first since I've got that big fraction. 14 plus 4 gives me 18, and then 18 divided by 3 gives me 6. So I'd be good from there. Again, this is just two examples and just to make sure we understand. The one on the left-hand side, that's a big fraction, so I would multiply by 6 first to get rid of my fraction. Make sure that I don't distribute that 6 into the top or anything like that. And then over here on the right-hand side, that's not a big fraction. The minus 5 there is outside of the fraction. So with that one, I could go ahead and add the 5 first. Those are just two examples. They're not on your notes or anything. I just want to make sure we understand the difference between a big fraction and a regular fraction or a small fraction. If you flip over to the back of your notes, just have a couple problems here. We're going to work on word problems. So this one says, I have a job that pays me $15 an hour and a flat fee of $50 for just showing up. How many hours do I have to work to make $1,200 to buy a new MacBook Air? And so with one like this, word problems are always kind of hard. And so what I find sometimes helpful is just thinking in my head. So this is a problem where a person's making money. And so I think for each hour that the person works, they're going to get paid more. And so if I think of making a T-chart, like you've probably done before, where I've got hours I worked and money that I've made, what I can do is that'll kind of help me create an equation if I can't immediately say I know what the equation is going to be. So with this, I can do 0 hours of work, 1 hour of work, 2 hours of work, and 3 hours of work. So again, my job pays me flat fee of $50 for just showing up. So if I just show up to my job and don't work any hours, that would give me $50 because I get $50 for just showing up. Think about it as a traveling fee for like a carpenter or someone who's working a trade or something like that. They're going to get money for just showing up for the service call. And then for every hour they work, they're going to make $15. So if I work 1 hour, I show up and I work 1 hour, I'm going to get $50 for showing up and then $15 for doing the hour's worth of work, which gives me $65. If I show up to work and I work 2 hours, so 2 hours worth of work is going to get me $30, and then add that to the $50, and that'll give me $80. 3 hours worth of work is going to give me $45, and then $50 for just showing up, so that'll give me a total of $95. And so what I should be able to see is, if I'm doing this, is that I'm increasing here by $15 each time. So this right here is my hourly rate. That kind of makes sense. For each additional hour, I'm making $15 more. And then what I have here is I have this, whatever number goes with the 0, so 0 hours, it's kind of my starting point. So if I have how much I'm going to make, so money is equal to right here, what I'm changing by, or what my pattern is. So that's going to be $15. And again, it makes sense, $15 for each hour that I work. And then this right here is going to be my starting point. How much I make by just showing up, which ends up being $50. If you remember from last year doing formulas that look like y equals mx plus b, your slope is how you're changing, and then your b is your y-intercept, or your starting point. That's what this kind of fits to. And so if I want to make $1,200, I want my $1,200 to be the amount of money that I make. It's equal to 15h plus 50. And so when I do that, I can subtract the 50 to the other side. Nice, easy two-step equation. I get 1150 is equal to 15h, and then I can divide both sides by 15. So when I do that, I get 76. Again, 0.6 repeating. So that's 2/3. So 76 and 2/3, and just make sure we understand what that means. That is 76 and 2/3 hours of work to get enough money to buy a MacBook Air. Okay. With the next problem, it says a plumber gets paid $30 for gas and then $20 an hour for a day's work. It says how many hours does he need to work to make $400 in a day? Again, some people can look at that and say, I know exactly how to write that equation, write it and solve it. If you're having trouble and you need help writing the equation, again, just think about I've got number of hours that I work and I've got money that I make. I always start with 0 because that'll help me get my starting point, and I can go 1, 2, and 3. So with this one, again, if I just show up to the job site as a plumber, I get paid $30 for gas for showing up to work. So that's my starting point there. And then for each hour, I'm going to get paid $20 more. So if I work 1 hour, that's $20 plus the $30 for gas, so that gives me $50 there for working 1 hour. If I work 2 hours, that's $40 for my hourly wage plus $30 for gas, so that gives me $70. And then the last one, if I work 3 hours, that's $60 for my hourly wage, and then $30 for gas, and that gives me $90. So again, my increase here is going up by 20 each time. And then right there, that's my starting point. So there's my change. And then here is my starting point, my SP. So when I write my equation, I can go money is equal to blank H plus blank. Right here is my change. Right there's my starting point. My change is on 20. That's $20 an hour. That should kind of make sense that the $20 goes with the hours. Each hour I increase by 20. That's my change. And then my starting point is $30. That's my beginning point for each day. Get my gas money so I can show up to work. So I want to see how many hours do I have to work to make $400. And so when I do that, again, I can subtract the 30 to get 370 is equal to 20H. Then I can divide both sides by 20. Oops. 18 and a half. 18.5 hours, or 18 and 1/2 of an hour. Okay, 18 hours and 30 minutes. So again, that's it.